Hello everybody, Sorlian here, and today we will be calculating the gradient of a straight line. And at the end of this video, you should be able to do exactly that, calculate the gradient of a line. So before we head into the content of this video, let's look at the scenario. So imagine you are placed in a situation in which you have to choose between two steps, step 1 and step 2. And at the top of both of these steps, you have $1 million in cash and prizes awaiting you. So in step 1, you have a normal step that you would find in the normal building with a normal slope. And in step 2, you have a very steep step. Very, very steep. It's not like the ones you would normally find. So you are in a situation you have to choose between step 1 and step 2. And at the top of both of these steps, you have $1 million awaiting you. Now, which step would you choose? So of course, the smart option would be to choose the normal step. And you may ask yourself, why is that the smart option? Because you walk it up and the slope is not too deep, it's not very steep. You walk up and you reach and you collect your money and that's it. Whereas if you choose the other step, which is very steep, it may be very difficult to climb to reach at the top. And it will be harder, before you can achieve that $1 million prize. So the reason behind choosing the smaller step is the topic that we're doing today, and that is gradient. So the gradient, or the slope of a line, as it is called sometimes, measures how steep the line is. And a simple formula without the actual mathematics that you can think about to remember to calculate gradient would be rise over run. So this rise over run tells us how much the y value changes for each unit increase in the y value. So for example, if we had a gradient like 3 over 2, this means we are rising 3 times and then we run 2 times. So that is what the rise over run is telling you. So that is the formula normally. So you can remember this formula, rise over run. So the actual formula to calculate gradient would be the change in y over the change in x. So for the change in y, it's simply y2 subtract y1. And for the change in x, it would be x2 subtract x1. So of course, this formula can be written in reverse. Instead of y2, we can have y1 subtract y2. But of course, this should be divided by x1 subtract x2. So it doesn't matter which one you put first. You just have to remember that the y1 and the x1 should be together in the same line. So for x1 and y1 and x2 and y2, so those just represent coordinates for a point. So if you have point A, which is x1, y1, this x1 and y1 is just in place of a normal coordinate. So this can turn into 3, 2. This can turn into, for B, x2, y2, this can be 3, 1 or something like that. Just an example. So let's look at some interpretation of the gradient. So if after you finish calculating the gradient and the number is positive, that means the line moves from left to right. So it rises from left to right like this. And if it's negative, so that means the line falls from left to right. So it will fall down like this. And if the gradient is 0, that means the line is horizontal. It goes straight across. So if the gradient is undefined, that means the line is vertical. There's no slope. So positive means it rises. A negative gradient means it falls. And 0 means it's horizontal. And undefined means it's vertical. So these are just some information that you can keep at the back of your mind after you finish finding your gradient. So let's look at an example. So the example says, find the gradient of a line passing through points A, you have 2, 3, and B, 6, 7. So first of all, we need to put down the formula so that we know the letter that we use to calculate gradient is small m. So the gradient is equal to the change in y over the change in x. So the change in y would be y2 subtract y1 all divided by x2 subtract x1. So first of all, we have point A. So we can label this x and y, x and y. So we know this will be x1, this will be y1, and this will be x2, and this will be y2. So the gradient will be y2 minus y1. So we see y2 in this case is 7. Is this 7? Subtract y2. So we see y2 is 7. Subtract y1, which is 3. And all of this will be divided by x2, which is 6. Subtract x1, which is 2. So the gradient will be equal to 7 subtract 3 is 4. All divided by 6 subtract 2 is 4 as well. So the gradient will be equal to 1 over 1, or we can say 1. So for the interpretation of this, 1, or you can say 1 over 1, means as we rise 1, this means as we rise 1, we go across 1. As we rise 1, we go across 1. As we rise 1, we go across 1. So that is what the 1 means. So let's look at another example. So example 2 says, find the gradient of the line passing through the points C and D. So for C, we have coordinates -3, 4, and D, 5, -2. So we know the formula to find gradient would be the change in y over the change in x. So the change in y would be y2 subtract y1, all divided by x2 subtract x1. So remember, if you want, you could have put y1 and then y2 here, but of course, if we do that, here must also be x1, and here must be x2. So really and truly doesn't matter. Let's put back the normal formula, which is y2 subtract y1 all over x2 subtract x1. It doesn't matter which one you put. So the gradient will be equal to y2. So let's label. So this is x, this is y, this is x, this is y, this is x1, this will be y1, x2, y2. So y2 would be -2 subtract y1, which is 4, all divided by x2, which is 5, subtract x1, which is -3. So the gradient will be equal to -2 subtract 4 would be -6 over 5 subtract -3. So these two negatives will cancel out and give you a plus. So 5 plus 3 would give me 8. So this can be simplified to 6 divided by 2 would be 3, -3. And 8 divided by 2 is 4. So the gradient would be -3 over 4. So what -3 over 4 is saying, as we rise, but since it's negative, that means you must go down. So what is -3 over 4 is saying, as we go down 1, 2, 3, we come across 1, 2, 3, 4. Then as we go down 1, 2, 3, we come across 1, 2, 3, 4. So we see we have a fall in the line. So that's what the negative gradient is saying. There's a fall. So let's look at the next example. So this one says, find the gradient of a line passing through the points E and F. So at point E we have 7, -5, and F we have -3, -5. So first of all, we set up our formula. So the formula is the gradient is equal to the change in y over the change in x. So we know the change in y is y2 subtract y1, all divided by x2 subtract x1. So the gradient would be equal to, so this is x1, this is y1, this is x2, this is y2. So y2 would be -5 subtract y1, which is -5, all over x2, which is -3, subtract x1, which is 7. So the gradient would be equal to -5 minus -5. So these two negatives will cancel out and give you a plus. So -5 plus 5, that would give me 0, over -7 minus -3 minus 7 would give me a -10. So we have 0 over 10. So the gradient would be equal to 0 divided by -10 would give me 0. So the gradient is equal to 0, and we know when the gradient is equal to 0, that means it is the line is horizontal and there is no rise. So it just goes straight across, it's horizontal. So when we see the gradient as 0, that means the line will go straight across. So let's look at another one. So this one says, find the gradient of the line L. So in this case, we see we are actually given a line L, well, a line segment L, and we are asked to find the gradient of this line. So we saw earlier when we were finding the gradient, all we did, we had 2 points and we used those 2 points to find the gradient. So similarly, with this line, if we want to find the gradient, all we need to do is identify 2 points on the line, any 2 points, and use those 2 points to find the gradient. So we can use this point here, and we can use this point here, some nice points. So we see for this point, the coordinates for that point would be, we go across -1 times. So it's -1, and we go down 4 times, -4. And for this point, we go across +1 time, and we go up 2 times. So to find the gradient, we use those 2 points to find the gradient. So let me work it right to the side here. So the formula to find gradient is the change in y, which is y2 minus y1 over the change in x, which is x2 minus x1. So we know we can call this x, we can call this y, we can call this x, we can call this y. So this can be x1, y1, x2, y2. It doesn't matter which one you put x1 and y1 as. Just make sure if this is x1, this is also y1. So let's go. So the gradient will be y2 would be 2, subtract y1, which is -4, all divided by x2, which is 1, subtract x1, which is -1. So the gradient will be equal to, so we have 2 negatives here, so that will turn into a plus. So 2 plus 4 would give you 6 divided by 1 minus -1. So those two, once again, we cancel to give you a plus. So 1 plus 1 would give us 2. So the gradient of this line would be 6 divided by 2, which is 3. Now 3 is the same as 3 over 1. So the gradient here is equal to 3. Now 3 is the same as 3 over 1. So let me show you on the graph what this 3 over 1 means. So 3 over 1 means we go up 3 times and we go across 1 time. So to move from one point of the line to the other point, we go up 3 times and we go across 1 time. So we can go up 1, 2, 3 times, and then we go across 1 time, and we should meet another part on the graph. So let's try that again. We go up 3 times, 1, 2, 3, and we go across 1 time to meet another part on the graph. And you can try that again. We go up 3 times, 1, 2, 3. We go across 1 time. And that is what the gradient means. Rise over run. You rise up the number of times at the top, and then you go across the number of times at the bottom. Rise over run. So let's look at the final example. Final example says, find the gradient of length L. So of course, you should know how to find this gradient. So all we need to do is identify 2 points on the line again. Let's identify 2 nice points. So we can take this point here. So we can take this point here, and we can also take this point here. It doesn't matter which one you choose. Just ensure it's 2 solid points on the line. So the coordinates for this point would be 1, we go across 1 and we go up 1. And this one we go across 2. Go across 2 and we go down 2. So to find the gradient, it will be rise over run, or the change in y over the change in x. So the change in y will be y2 subtract y1 all over x2 subtract x1. So the gradient would be, so let's call this x1 and y1 and x2 and y2. So the gradient would be y2, which is this one here, -2 subtract y1, which is this here, all divided by x2, which is here, subtract x1, which is here. So the gradient will be equal to -2 subtract 1 will give us a -3 All divided by 2 subtract 1 is 1. So the gradient will be equal to negative 3 over 1, or we can just say negative 3. So we see negative 3 is the same as negative 3 over 1. So let's interpret what that means on the graph. So that means as we go down 3 times and we go across 1 time, we should move from one point of the line to the other. So let's try from this point here. So this means we go down 3 times since it's a negative. So we go down 1, 2, 3. And then we go across 1 time. And we should reach back on the line. Let's go down again 3 times. 1, 2, 3. And we go across 1 time. We should be back on the line. And if we go down 1, 2, 3 times. And we go across 1 time. We should be back on the line. And that is what the gradient tells us. The rise over the run. As you rise, how much you rise and how much you run. Or sometimes you don't rise, you go down and then you run. Either run from left to right or right to left, depending on the sign. So for positive means you go up, negative means you come down. For the running part, a positive means you go to the right, a negative means you go to the left. You go in the negative direction. So with that, we have come to the end of this video. I trust that you now have a solid understanding of how to find gradient. Remember, gradient is just the rise over run, or the change in y over the change in x. Just identify your values in the point, and then it's just a matter of substitution and working it out. And make sure to look at your signs. So, of course, I must leave you with some questions for you to practice on your own, to practice this skill. Now, the gradient is very important. It comes every year in CSEC, so you must have a good understanding of gradient. So you can find the gradient of these points that I have here. So, good luck practicing, and ensure you actually practice, because practice makes perfect. So until then, I'll see you in the next video. Take care.